podcasts out. They're really fun. Oh, I hope everyone had that. So our second panelist is Navya Mehta.
Wait 1 second, sorry. Everyone's okay if I record this session, right? Okay, perfect. If anyone's not okay with it, just let me
know. So I repeat, our second panelist is Navya Mehta.
So, hi everyone, I'm Navya. I'm currently a third year undergrad studying computer science, finance, and statistics here at the University of Waterloo. Had a couple stints in data science in the past, worked with like capital markets, insurance, supply chain, and stuff like that. And currently, I'm working on like a security analytics product at Splunk this summer. And yeah, that is what it is.
Great. We have our third panelist is Ryan Oren.
Hey everyone, nice to meet you. Nice to meet you all. I study systems design engineering here at uWaterloo. My past, I've done a ton of different things. So I've actually completed, well, I'm in my 6th co-op right now, but I've worked for a bunch of different tech companies, working as a data scientist. My work has ranged from more technical, more software engineering roles where I was actually helping build models, deploy models, etc. And currently I'm working as a data scientist at Facebook. So yeah, I'm more than happy to share everything with you guys today.
That's great. And our last panelist is Mujtaba Siddiqui.
Hi everyone, my name is Mujtaba. I'm in geomatics at the University of Waterloo. I have a predominantly data engineering background, but you know, I've done some data science work as well. Obviously, they're very interchangeable. You guys usually work on the same teams. Currently, I'm working as a data engineering co-op at Ecobee. And yeah, nice to meet you guys.
That's great.
Alrighty,
so let's dive right
into
into the questions.
All right, thanks everyone for sharing your background. And yeah, so those are our panelists for today. And to get started, I guess our first question is, what advice would you give to someone who wants to get into the industry, but doesn't have a lot of coding experience? So I guess we can go into order of maybe how we introduced ourselves. So maybe Jay could start us off.
All right, I think there's like multiple ways of getting to data science positions. And there's like engineering routes where you can be a data engineer first and then move towards data science, or you can be a data analyst first and then move towards data science. And I think SQL is not very coding intensive. It's simpler to learn than I guess most coding languages. Although the bar is quite high, to be good at SQL, it does take a lot of effort. But anyway, I think that people who don't have coding experience right now, it's probably easier to get in the industry that they're interested in. So find your niche and try to be a good data analyst in that area. You know, I'm actually interested in what like Rand, wait, am I pronouncing your name correctly?
Yeah, you are.
Yeah, I'm wondering what you think about this, because I don't know what data science work Facebook does, but I'm guessing it's a lot of analytics, right?
Yeah, so this is kind of a separate discussion. I think data science in general, from what I've seen, it's a very big umbrella term. So it's more of a spectrum where it varies from more technical, almost borderline software engineering kind of work. And then on the other side of the spectrum, it's more analytics, business, strategic focused work. So yeah, I guess it kind of depends on where you see yourself fitting on this spectrum. If you are more interested on the business side of things, then I would highly recommend, if you don't have any data science experience, getting your hands dirty with, you know, maybe with online data sets, doing some analysis on those, sharing your analysis, maybe through like Medium articles online, or, you know, just getting engaged with more analytics analyst focused work. If you're shooting for the other side of the spectrum, which is more machine learning, software engineering, more technical, and just more technical work in general, I would say that things like, you know, finding data sets online, building models by yourself, maybe creating an application, so some kind of website where you deploy your model into the application as part of the product, and working on more software engineering-y type products and showing those on your resume and posting your code on GitHub. That is probably the route to go if you want to go more technical. So I think the first thing is maybe kind of deciding which type of data science is more for you.
I think just to piggyback on what Rand said there is, yeah, data science is a massive spectrum, but one thing that if you don't have much coding experience and you're coming from some other discipline, you can always utilize that domain knowledge. That's what sets you apart from, you know, most applicants that would come with coding experience might not have that domain experience. So yeah, if you're going for that business side of things, like Rand said, and you're from a business background, you know, it's a common saying, data science is 80% data cleaning, or it's all about the data. It's, you know, code is something you can learn and you will learn rather quickly. But if you have that as a starting point that other people don't have, you can leverage that side of it, right? So if you have a business side knowledge, you know, let them know that in your interview process.
Yeah, I mean, fundamentally, there is a reason that auto ML does not dominate the industry, because at the end of it, regardless of best practices that exist with the way that analytics pipelines are built, at the end of it, the way that each model has to be deployed or each use case is served is fundamentally different, which mandates or necessitates the need for like domain experts. So yes, I do agree there is a spectrum. Yes, you can be in like a business focused or an engineering focused role. Making that distinction early on is important, or you might want to like, play around with both of them over your co-ops. But it's important not to discount a lot of the subjective skills beyond just programming that go into like deploying a successful data science work product.
Okay, can I pitch in? Okay, I'm just wondering what kind of subjective skills are you referring to?
So here I can talk about anything with, say, for example, when you're going about like feature engineering, for example, a decent amount of understanding of, number one, the data set itself, like whether some kind of relationships are possible, whether you have some kind of confounding effects you need to take care of, whether it is actually feasible in like in a business sense to be able to engineer like derivatives of certain features. For example, when you're dealing with like a mortgage industry, there are like a lot of compliance accords that you need to like be able to work with. So the ability to communicate with like business stakeholders to identify, okay, maybe you cannot use any location data or anything with gender or race, because that effectively might compound bias in your model. Or how exactly do you, when you have a team that's developed a model, how exactly do you communicate to the user, to the business itself? Because at the end of it, when you're dealing with something simple like you're building a linear regression model, you can use your coefficients as a proxy for how it's working on like the underlying data set. Increase model complexity, go into say neural networks, or even like stacked classifiers, or any kind of model that goes beyond mere regression. What does SHAP value mean to a business user? So it comes down to how exactly you present your findings to an extent that the business is actually comfortable with deploying it, because at the end of it, models are subject to audit.
Yeah, I'll pitch in here. I think those were all great points, and I completely agree with that. And I think that what you mentioned something very important, which I think deeply distinguishes between data scientists that are very strong at what they do versus those who have who are not able to provide as much value. Because deeply understanding and making that connection between the technical work you do and the statistics behind everything you do, making that connection with what does the business care about, that is a very, very difficult connection to make. And I think that it's good that all the students in this meeting, I think it's great that you guys are hearing this early on, because you made a very, very good point. But I will say that it's okay not to know that right away. I think there's a lot of you need hands-on experience, and a lot of these things you do pick up just by working and being part of an organization for a few months during a co-op. I think that will greatly expand your skill set. So I guess I would advise everyone here to not be too overwhelmed and expect to be domain experts very, very early on. But just know that in the future, when you do start working in this field, that is one of the main things that distinguishes a good data scientist to a really, really great one. So that's a very good point.
Yeah, I just pitch in one last thing. A very good example of like the technical business connection and when it succeeded, when it failed, was it was actually a recent blog by Dropbox where they talked about like a feature where you're able to index into your images via text search. So you have photos of text, or you say have a photo of a picnic. You want to be able to search picnic and actually get that photo. And so the discussion was actually interesting because they said that when they actually build the models to test how well it works, the best results were obviously using state of the art methods. You use, say, a kind of like a convolutional encoder to encode your images. You use like some kind of like fairly recent, use like a BERT or a Distilbert or any of these language models to encode your sentences, train some kind of similarity model, and you have something that's state of the art at understanding your text query. But they quickly realized that even though that was the best at getting their matches, that had zero business value. And by that, I mean the scale that Dropbox operates at. In order to productionize these kind of models, you need to run it on GPUs, and the cost was simply unfeasible. Like the project would have net loss if they actually went forward with the approach. So the way that they actually went around the issue, and the way that they went back to basics. How can you use glove embeddings? How can you say cache these embeddings so that you're not trying to dynamically generate them? A lot of these things that are seen as counterintuitive, seen as things that might dampen your accuracy, but they end up adding tremendous business value in the sense that the feature can actually be productionized.
That's some great insights given on how to exactly start, and some great examples as well. So let's move on to the next question. What would you suggest is the best way to prepare for a DS interview?
This is kind of a subjective question because there's like, as Ran said, there's data science is such a broad field that a lot of jobs which are not, they might even be data engineering, but they might just call it data science. So it really does depend on the role. I will talk about I'll try to cover the lowest common denominator here, right? So which will help you in most cases. Personally, not a big fan of lowest common denominators though, because you should be more focused in your approach, ideally. But I think that they might ask you things you've already done. So let's say you worked on a project, they will for sure ask about that because they want to know how well you did something that you already have done, and how well you understood that. So spend some time, learning that and figuring out that, okay, I used, for example, as Navia said, I use glove embeddings to embed my words. And okay, they might ask you, why do you use that? How do you store that information and stuff like that? So have that knowledge ready. Second is that if it's a technical interview, they might ask two things. One, if they're a Python shop, so if they do a lot of Python, they might ask you a simple like Python FizzBuzz, which is just like a lead code question. And second is they might ask you SQL stuff if it's more on the analytics side. So understanding these three things and knowing spending time kind of learning them is a good idea. Yeah, I think that's like the general data science interview. Plus, they might ask stuff like, if you've already done it, for example, okay, what's overfitting, what's underfitting, like those basic questions you can just find online. But yeah, I think that's generally covers most of it from what I've seen.
Yeah, I think here I have 4 quick pointers to make. Number one, yes, being able to justify the decisions you've made when designing previous models. Why exactly was a certain loss metric chosen? Did you develop a custom loss metric? Why exactly were certain decisions made about that? What was your architecture like, etc., etc.? Secondly, as broken as interview processes are, most data science interviews tend to degenerate down to software engineering interviews where, you're going to end up doing lead code. It's a necessary evil at this point, so might as well just prepare with it. The third, and this is actually the most interesting aspect of it, and this widely differs from interview to interview, but it's machine learning systems design, which I think is by far the most interesting. And the main idea here is that the industry as a whole has reached a phase where trying to design new models from scratch, like rebuilding your convolutional layers, rebuilding modules, is never going to help you achieve the best results possible on a particular problem, because the years of academic research we have, it's transfer learning as a field has shown great promise. And so a lot of interesting questions that I've encountered in the past is, you say you're given a very wide problem to scope, and okay, this is an example. Say I have let's say you have photos on Instagram, like you upload a photo. Can you design an algorithm that can suggest friends that should be tagged in the photo? How exactly would you go about this? So it's not necessary for you to actually build a new model from scratch. You can use state-of-the-art approaches. Maybe, you want to use like a RCNN to get bounding boxes around faces, and then you want to use like some kind of convolutional encoder that like encodes the faces of all your friends and encodes the faces identified in the photo, and then a similarity matrix that just tells you whether a particular photo is a particular person. The idea here is more about how can you use what the industry has produced so far to be able to make new interesting applied applications. And so an example of this was just like auto tagging, or just another important aspect of interviews in my mind is showing sufficient theoretical understanding of machine learning, specifically if you're targeting more technical roles. For example, instead of like going beyond an API to train models, going beyond scikit-learn or Keras, how exactly do dense networks actually function? This was actually one of my questions in the interview, where he was like, can you design a forward pass for a fully connected dense neural network? Imagine I give you the parameters, I need one layer of 10 nodes, one layer of 5, and then an output layer of 3. Can you design the entire flow of that model? So the idea here is, do we know how what are the dimensions of the weight matrices are, how the bias matrices interact with them? So yeah, it's just ensuring that fundamentals are sound so that it helps you see the big picture when it comes to machine learning better.
I think one thing I just want to add to that, everyone's talked about, providing great resources and points about the technical side of interviews, which, yeah, do lead code. Make sure you know your Python and SQL and all of that. But again, it goes back to that same thing that Rand mentioned, is what sets you apart in an interview. And I mean, it depends on the type of interview, obviously, because every company interviews differently. But it's getting to understand the company and what they do, and being able to integrate that in what you're talking about. So, you can go in with the most technical knowledge, but if you have no idea what the company does and no idea where, things you would like to do fit in, I feel like that doesn't help. That would help your case a lot more, in, standing out in a slightly different way. And, not all interviews allow for that kind of thing, where they're very structured, but a lot that I've been to are very open. It's more like a conversation, and being able to have some of that background knowledge really helps.
Yeah, sorry, just to add on here. So this actually kind of ties into one of the questions that we got from our attendees. So they wanted to know how important is theoretical statistics knowledge during interviews. So are DS interviews usually programming focused, so I guess the more tech side, or more business focused?
Okay, great question. I'm going to chime in here quickly because I didn't get
sure.
to take on the previous one. I completely agree with everything the panelists said. I think they gave great insight. But I think because data science, unlike, let's say, product management or design, or maybe some back-end jobs, because it's such a wide encompassing umbrella of so many different kinds of roles in the spectrum that I mentioned, the most interesting tip that I would actually give you guys is knowing how to prepare well for these interviews. So I wish that I could make a quick Google document right now and give you guys my 3 biggest pointers on what to do. The problem is most of it would be pretty useless. It completely varies depending on the company, depending on the team you're interviewing for. My advice to all of you is, if you have an interview, whether it be through Waterloo Works, through LinkedIn, understand what you're interviewing for. when you actually read through the job description, there will be clear points that will sort of guide you towards what preparation you need to do. If you're applying for a data science role and it mentions SQL, it mentions general analytics, etc., past experience doing more maybe PM work or more product focused work, that's very likely not going to be a machine learning engineer role. So it is very likely you will not be asked how to build an XGBoost classifier from scratch. It's very unlikely. So in that case, it might be a great idea to practice SQL, to practice maybe more product focused questions, etc. Another example might be on the other side of the spectrum. If you see a job that says, titled machine learning engineer, and in the description, it clearly says you might need to know Python, you might need to know C, SQL as well, you might need more advanced statistics knowledge, etc. I think in that kind of case, the most efficient way to allocate your time would be leak code. I think that's very important. A lot of the times you're going to be asked some kind of algorithm or data structures question. Statistics, so understanding generally at more of a high level how all of these models actually work, having an actual fundamental intuition as to how each model works. And then also some other things like maybe a few system design problems you should prepare for, and some of the things that Navi mentioned as well. So I guess my general advice here, and it kind of pertains to this most recent question about how well should you know statistics. I think sort of understanding how to read through a job description, see what company you're working for, maybe go on Glassdoor, seeing what kinds of questions you should expect on the interview, understanding how to formulate a process for preparation. That is actually the biggest thing. And one more thing I'll say, this doesn't just apply for interviews. This is what I've been using in school as well. So I've taken like random calculus courses and all these different courses where the amount of material, it's just not feasible to have a deep understanding of all the material before a final or before something like that. Understanding sort of what to prioritize is just a really, really important skill because there's natural limitations on all the information you can absorb and how much preparation you can have. So I think that's just something generally I wanted to mention, and that applies for this most recent question with statistics as well. But I do recommend that as a data scientist, definitely all the baseline statistics. So this is your basic probability, this is your Bayes theorem, this is your probability distributions, this is being comfortable with specifically normal distributions and understanding how real world distributions look like. I think that is all kind of a baseline, which you'll probably learn in an intro stats course. So yeah, that's my take.
Right, thank you. And actually, just to add on to that, we got another question. So I know that we do have some panelists who have worked at Facebook or is currently working at Facebook and Splunk. So they wanted to know what are data science interviews like at those two companies, so Facebook and Splunk.
Well, I guess I'm not sure who's working at Splunk again, but I guess I can speak about Facebook. So in the past, I have worked in multiple data science roles. So just a little bit of background, like after second year, I did a data science internship at TD Bank, one of their like incubators or one of the teams at TD. And then after that, I did 2 work terms at a company called Wish, which is an e-commerce platform. And now I'm actually working at Facebook. The reason why I prefaced this with my previous experience is because Facebook is actually a pretty different, I would say, than most data scientists' role. So for Facebook specifically, this is a very product-facing role. And what that effectively means is the majority of your work is actually dealing with you're sort of a proxy between product managers and software engineers, where it is very important to have a technical understanding of how the models and the backend infrastructure work. But you need a very deep understanding of product sense and what to actually understanding the users of the product that you are focusing on. So for Facebook specifically, I would say SQL is very, very important because you're definitely gonna get tested on that. And I'd say spending considerable amount of time on more product focused questions. So I would literally do mock interviews with product managers that I knew because you sort of have a technical Interview, well, I think I had 2 or 3 rounds, but I think one of the rounds is more technical in nature, and then one of the rounds is a little bit more product focused. So I would say those 2 things, SQL and then just general product sense. Those are probably the 2 biggest things I would say.
Can speak to my interview experience at Splunk, and my role was fundamentally extremely engineering focused. Yes, it's on an analytics product, but it's much more on like engineering the systems that support the product. So there were, some of these more analytics focused, like systems design questions, but predominantly it was about, I think it was like 30 minutes, but can you solve this very generic engineering problem? For example, say, uh, take a string manipulation question, or take something that's more, suppose you were supposed to create this endpoint and deliver the service to consumers. How would you make like key database decisions so that your product can be so that inference time and delivery time to consumer is the lowest, stuff like that. So it was a mix of systems design and like real-time coding on Python in the interview. But again, I cannot speak to the more product-facing roles at Splunk and how they really function.
That's great. Any other panelists would like to add on to that, or shall we move on to the next question? Okay, so next question would be, what are some of the skills or side projects on a resume that make a candidate stand out at a DS position or at a data science position?
Again, I'd say that Ran already mentioned that there's like such a huge spectrum of positions you can call DS positions. It's hard to say, okay, if you have this in your resume, it will work. For example, if you have SQL in your resume, looks good for positions Ran applied to, but probably not so much for positions Navi applied to, or the position that I work in. But I guess that makes sense. But the point, so what I would say is that kind of going back to the first point we mentioned, which was identify where you want to be in data science. Do you want to be in more back-end engineering heavy roles? Or do you want to be in data engineering? Do you want to be in analytics? Or do you want to be more on the machine learning side? And then focus trying to get skills in that area. And so did someone ask this question like in chat or an attendee? Because I think what would be helpful is that if they can come up and say, okay, this is what I'm interested in. I want to go towards analytics or machine learning, or like that would give more context, right?
No, this was just a general question that we made before, but if any of the attendees would like to add on to this, ask about some particular positions, feel free to do that.
I can actually answer for data engineering positions. I think Mushtaba can add to that. For data engineering, depends on, first of all, like what kind of company it is and what kind of stuff they do. So my company uses Python a lot. Some might use Scala or PySpark and things like that. So Python is for sure, I'd say, a pretty generic skill to have. So that always looks good. Second is that if you're working with data, you're most probably going to be using SQL or some form of SQL. So learning that is, again, something great to have. Third is so there's like these other specific skills like Airflow and I'm not sure, I guess Airflow is one good way of scheduling your pipeline. So that if you have experience in that and your company uses Airflow, it's probably a good thing to have in your resume.
Yeah, I mean, Jay, you mentioned so from the engineering side of things, I think everything Jay mentioned, those are great tools to have in your project. But I think what makes a project stand out more is if it's something that you chose to make yourself out of something that was interesting to you. Because everyone has seen them. There's tons of Medium articles, YouTube videos, etc., of general projects that you can, put your little spin on. But if it's something that you found a problem for and can relate it to your work and make a solution for that, or it's just something you like that you think is cool. So like a cool data engineering project I saw was, and it related to ML engineering slightly, is someone made their own model to create a playlist for themselves on Spotify, and they did all the back end work for it so that it basically creates that playlist for themselves, right? And so that's not something you would see anyone just make, but it hit all those skills, right? He had Airflow controlling it. He was using Python, working with APIs. So if you can get something you really like, it will probably hit the areas that you want to show, and you'll use the variety of tools. So there's never really one project that will stand out consistently to everyone. But if you can do that, then you'll probably trying to make it a better project will hit so many different tools and aspects that'll make it a better overall project to at least talk about it in an interview.
Yeah, I'd add on something here, and this is specifically focused on more machine learning and engineering focused DS roles. But what works well is also, as just mentioned, working with that entire spectrum of the development cycle. Identify a problem, build, like actually work on building models, explore like a lot of the decisions that go behind like metrics, like architecture, so on and so forth. An important part is also productionization, because ML ops is equally important when it comes to deploying these analytics driven products, which is, can I improve my inference time? Is there services I can use? Maybe you want to build experience with TensorRT. Maybe you want to build experience with CPython, stuff that helps to accelerate inference time for your models. So because from the moment you build your model, let's just take YOLO, for example, which is like an object detection model. Recently, there were attempts to like increase its frame per second processing by almost 10, like an almost 10x increase by using knowledge distillation processes, where they actually took a larger model and compressed it down to something that could run inference on CPUs. So just dabbling with a lot of that through the course of your project is interesting, where how can I prune this? How can I make it more efficient? And yes, having like a basic web server where you can show what you've been working on. And this obviously depends on where your interest lies, but maybe once you have like a lot of that web infrastructure and a lot of that set up, that's going to easily translate over between projects. And that also gives you the opportunity to now play around with different problems. Maybe you're interested in computer vision, so you're picking up like, say, some issue about identifying stuff in images. Maybe you're interested in natural language processing and you want to deal with identifying sentiment. Like Twitter sentiment is, I think, one of the most famous projects there is. The other one is actually identifying sarcasm, which is far more difficult. Stuff like that. That now gives you the opportunity to just plug and play with the rest of your development cycle and then explore problems in very varied fields in machine learning, everything from reinforcement learning, unsupervised, semi-supervised. Maybe you want to, like, you just get a large breadth of problems to work with, and that diversity plays well into a resume.
We do also have a question in the chat. Do you think doing a statistical analysis concentration would benefit me a lot in the industry of data science, or would it have a minimal impact?
Oh, I'm starting this? All right. Yeah, for sure. I mean, it will probably not have that much impact if you're working with very back-end heavy data engineering roles, because you're not going to be using it as much. But it would for sure have impact in most of the data science positions that I can think of. Yeah, I mean, I'm sure the other people can answer this question better, but I think that for sure it will have a great impact on the positions that you can do.
Do any of our other panelists want to add on to that, or we actually have another question? So if everyone else is okay, then I can ask the second question. So someone wanted to know, what online courses would you recommend to get started with data science, mostly data engineering or machine learning roles?
I can give a little bit of a take on that in terms of data engineering, a little bit of machine learning. I think Navia knows way more than I do. So in data engineering, there's actually a book by O'Reilly. I can't remember what it's called. I think it's something to do with data engineering. I will post that in chat. I forget what it is.
Is it designing data intensive systems? That's a distributed system.
Yeah, that's it.
Yeah,
So,
I highly recommend that one too. It's great.
Yeah, that's a great book. And yeah, I think, yeah, just like do that. And because it is actually kind of hard to learn data engineering and do data engineering specific projects. So I'm not sure to be. I think that's a good book. I don't really do online courses much. So probably Mushtaba or Navia have better answers.
So, I mean, sorry, Navi, you want to go ahead? I can just continue the data engineering and you can hit the machine learning at the end, I guess. But yeah, exactly what Jay said. O'Reilly every year comes out with free released books, which kind of, I think, after a certain time period, they'll release them free. So I have a whole folder full of books on like PDF books on my laptop. And one of them is the one that Rand mentioned as well, is designing data intensive systems. And I mean, if there's a specific technology you want to use, that's where I think courses are really good. But for learning general data engineering or even machine learning principles, either finding a PDF, like a textbook, is usually your best bet because it covers a really large spectrum of knowledge. Courses I think have been helpful. Like one of my managers in one of my jobs where I just started kind of got me on a course to get better at Spark when I was first getting into data engineering, right? So for learning a specific technology, that's where I think online courses are really useful. But for learning general, larger scale concepts, go look at some textbooks. They're great to have a ton of information.
Yeah,
especially by O'Reilly. Sorry.
Oh yeah, I'll just add on something here, and this is actually a book that was recommended to me by my manager on one of my previous co-ops at BMO. It's called the Elements of Statistical Learning. The by far the most comprehensive book that exists on foundational machine learning, more traditional approaches that like you don't even need to get into deep learning to be able to design products that add value to like analytics cycles, because a lot of the book touches on like different methods for inference. How exactly can you optimize models for like specific use cases where there are certain patterns in the data that can render certain approaches more useful than others. And it is extremely theoretical, one of the most comprehensive books I've ever found out there. When it came to a more fundamental introduction to deep learning, I think the course is called Deep Learning with Keras. It's on edX by IBM. It's a fairly short, it's a 4-week course if I remember correctly. But I thought the course was really useful because it touches on things on both sides of the spectrum. You're learning how to play around with the Keras API itself and trying to build like basic models, training, inference time, all of that, while at the same time you're being exposed to how the theory behind backpropagation works, how exactly certain matrices are trained, how do you tape your gradients, for example. So I think it's a good balance between the theory and the application side, and it just gets you started. It's a fairly vanilla overview across all subdomains.
Yeah, I'll mention one more thing as well. So first of all, elements of statistical learning. I've heard that as well, where that's apparently a highly recommended theoretical book. I'll also recommend, if you guys want a good introduction to some more theoretical machine learning concepts, there's this really famous Coursera course. I think it's one of the most popular courses on Coursera. It's by this guy Andrew NG, and it's pretty much like, it's a really popular course. I think it's called Introduction to Machine Learning, and there's a specialization as well. But that course on Coursera, I took that and I really enjoyed that too.
Yeah, that's a really good course. Even I'm doing it right now. Any other panelists would like to add on to that question, or should we move on to the next question? Okay, cool. So this is a next question. Do any of the panelists have any advice on how to find your niche in data science? What are your thoughts on being more of a generalist or dabbling in multiple fields versus diving deep into specific niche? And also, how did you find your niche?
That's actually a pretty interesting question, because I came into data science because I was a good generalist, and because it gives, it's one of the fields that allows for being a good generalist, right? Because there's so many different things you can do and you can touch. But as time went on, I feel like being an expert at something and kind of going into a specific niche is like, I would enjoy that. I would like to be a data engineering expert eventually, right? I suck at it right now, but hopefully eventually I can be really, really great at it. So what I suggest is go around, try different things, go in different data science roles if you can, or data analyst roles, or even engineering roles, and see what you like. Are you the kind of person who would enjoy being an analyst, or are you the kind of person who would enjoy doing like engineering? And then just like slowly develop your skills on that by doing a lot of projects on your own. That's what I suggest.
When it comes to machine learning, I'll firstly preface with the fact that people take years to find their niche. The fields are broad. State of the art research is well funded and rapid across these domains. Two things that I think work really well. This is purely my opinion. First of them being undergraduate research assistantships. I think they are a fabulous way to just try out what research looks like in a particular field over the course of a study term. You know, you might want to message a professor who's working on some computer vision research and work with him over the course of a term and just see whether you're enjoying the kind of problems you're working on. I mean, obviously, a field is very huge. There are a large set of benchmarks or like standard problems that are used. For example, you can have like image segmentation, deblurring, denoising, so on and so forth. The list goes long. But you may not be able to touch upon all of them over the course of a term. But I think doing these kind of research roles is a good exposure to what a particular field is like. Apart from that, just looking at some of the research output that comes out of a lot of your top conferences. Look at Neuro IPS, look at CVPR. CVPR, by the way, is the best of the best when it comes to computer vision. You would have a good idea of the kind of problems that you're working on, the kind of areas that SOTA is currently struggling with, and where new research is being directed at. For example, one of the most interesting ones that I came across recently was that when you're using generative adversarial networks to, like, you know, recreate images, one of the most famous metrics that they actually used to evaluate these benchmarks, I think it was called PSNR. They realized that that metric was flawed at actually capturing at how humanly distinguishable these images were. For example, images that were too artificial with very smooth boundaries, they actually scored higher on the metric. So one of the most interesting problems was, how do we actually design a metric, that loss metric, that's actually differentiable but still captures what like we humans perceive as being a real image. So there are a lot of these interesting problems that come out of these conferences. But yeah, it takes years. I mean, I don't think any student has a niche, so to speak. It takes years to develop one. I think the course of university is just a continuous process of trial and error, of experimentation, just playing around with what you can get your hands on.
I'll give my 2 cents really quickly here. I think the biggest advice, like I'm actually reading through some of the chat right now, and I'm hearing like, you know, some people like failed interviews and stuff. What I will reassure everyone is that you're not supposed to know. Like everyone here is probably between the age of like 18 to 22, 23. No one knows, no one can know exactly what they want to do. And I think that's very, very normal. And that's why my advice to everyone is to be open, apply, get experience, get your hands dirty. The best way to learn is by doing. To this day, I don't have it all figured out. I don't know exactly what I want to do. I don't know exactly where I see myself in 5 years. And this is something that I've started to think about more now since I'm approaching graduation. I'm almost conflicted between whether I want to stay as a more technical worker and stay maybe on the more research focused side of data science, or do I want to go into the more sort of data strategy, product focused roles. So it's normal not to know. And I think to just comfort everyone, once you get your hands dirty, once you get through and do some co-ops, I promise you, you will sort of naturally go towards the direction that fits you best. So it takes time. Don't stress yourself out too much.
Yeah, I mean, I think Navi and Ren both said it. I mean, I personally don't have a niche. I don't think most of us have niches. You have to, it takes a long time and to try a lot of things to find a niche. You know, even if you've done one co-op, 6 co-ops, worked full time for 3 years, you might not have a niche, and that doesn't, you know, that doesn't affect anything. And for sure, there's also space for generalists, right? I think we glossed over that part of the question a little bit, where should you value being a generalist or having a niche? Especially with, even if we're talking within the spectrum of data science, where we've mentioned before, there's the analytical side and the engineering side. At smaller companies, you might be, you know, 1/3 of the entire data science department, right? Like you might have to do the data engineering side and the analytical side. In that case, being a generalist is great, right? So you're going to have to do the analysis, and then you're going to have to deploy it and do the data warehousing and everything full end to end, right? And so, yeah, at the beginning, try to pick up as many skills as you can, and just keep trying to learn more all the time. And eventually, if you find something you really like, then you'll find a niche. And that's not even necessary, right? You can always survive as a generalist. It's not like a niche is a necessary thing.
All right, thank you everyone for sharing. So there was another question that came up in the chat asking what are everyone's thoughts on a master's or PhD to work in the machine learning, data science, AI industry?
Well, it's interesting because like I can't answer. I'm undergrad still. So, and personally, I don't really plan on doing a master's or PhD just yet. And the roles that I'm looking at maybe going into don't require it. But there's some roles which 100% do. So I worked at one lab, which was very research heavy. And every single person at that lab was either a PhD or a postdoc or had completed that. Yeah, I think it depends on person to person and role to role. I think Navya can probably answer this in a little bit more detail because like he's very into research, and that those roles usually require masters or PhD.
I just do a very quick preface. The way that any machine learning role requires this kind of background today can be, you can mimic it with how a lot of computer science roles also requires similar like profession postgraduate education when you roll back say a decade or two. The idea is that depending on the extent of your exposure to that field in the course of your undergraduate education, there are instances where people view a master's or a PhD as a way to make you technically adept enough to interact with state of the art. For example, not a lot of undergraduate programs today, and I mean, no program, as far as I know, rigorously or academically touches upon a lot of these, a lot of recent advances in machine learning in a theoretical capacity. And that is one of the reasons that a lot of people do go on for master's or PhD, although it's a very personal choice, where it is to be able to get a practical and theoretical experience to be able to actually work with these models at scale. And this is as I said, this is specifically relevant for research driven roles because in order to actually produce valuable research output, you need to be able to understand where state of the art currently stands because you're often developing derivatives off of those. But there is absolutely no hard and fast rule because based on your own experiences, you can obviously be an undergrad who has the right skill set to enter a research role. On the other hand, you might want to be a generalist who plays along with, who wants to be like a research engineer, essentially playing around with both the research and the deployment side of things. So there are a lot of possibilities. Most people tend to view postgraduate education as a way to be industry or academic researchers, but being a generalist across the spectrum allows you to dabble with a lot of stuff.
Right, perfect. Thank you so much. So just as we wrap up, we have 4 minutes left of this panel. I guess the question that I kind of just thought of was looking back to, I guess, your first data science related co-op, what is one piece of advice that you would give yourself?
I tell myself to slow down. You're never gonna know everything. And you know, my first co-op was a data analyst role, and so I was purely on the analytical side, and my next one was a data engineering role, so I was purely on the engineering side. Um, and I think it's just everyone, you know, like for me personally, I need to slow down because I was just trying to take in as much information as possible. Um, and it becomes a kind of, I just want to learn all the time, and you never really take time to think about what you've learned and where you actually are interested in going. And I only realized that recently, right? That wasn't even like going back to my first co-op. I could have done that any point within the past year, right? Because I only stopped to do that like a year ago. And just take a second, even after a couple co-ops, just to figure out what you're interested in and what you want to do going forward, rather than everyone, you know, you can get really focused on going full steam ahead, learn, try new things, get in here. And sometimes you need to just take a step back and see where you are and where you want to go and reposition, rather than just getting stuck in the work. And I think that's really useful and probably would have saved me some time in experimenting.
Okay, just to add on to that, I can't, I can't reflect back on like so many years ago, but I can reflect back on what's happening right now. Something that I'm trying to do right now, for example, is that like weekends, usually like I just keep on like doing the things that I was doing before. So just like keep on working. And something that I would suggest is like, you might also want to do that if you're trying to prove yourself in certain positions. Let's say you've just entered a data science position. Everyone's a seasoned data scientist. You don't know shit. Like you don't know how anything works. You might want to spend extra time learning, right? Just like Mushtaba said. But taking some time off to reflect on things that went well in the previous week and what you want to do in the future can actually add a lot of value. So look, for example, right? Something that we're doing right now is, and this is very specifically data engineering, is moving from Airflow 1 version to Airflow 2.0 versions. And that requires a lot of work in terms of just restructuring and redesigning the pipelines. And either something we can do, what I can do on my weekends, is just digging through the different pipelines and just like working through them and changing things to make sure that it's viable, we can actually make the move. Or another thing that I can do on my weekends is take a step back and look at what we can use from Airflow 2.0 to improve our processes and improve our pipelines. So I'd say take some time off to look and plan into the future. That's probably something that I would suggest, and it probably adds a lot of value.
Yeah, I'll pitch in here. Great advice so far. My advice is there's 2 main things I would say that I've learned. First being, be very, very open to doing anything. There's so many different business needs. Like I have done everything from complete data engineering work in it. Like I was working as a data scientist when I was at Wish, actually. There were some weeks when I was working as a data engineer. There were some weeks when I was only working with the machine learning engineers that we had. And there were some weeks when I was working with product managers. So be open to doing everything and just absorbing as much learning as you can throughout the co-op term. Second thing, and this is something that I've done every single co-op term, I sit down with my manager, my mentor, which I'm sure you guys will all have. And this is what I tell them. I tell them, I am here to learn. I want criticism. I'm open to constructive criticism. Like whatever recommendations that you have, like I do not get offended. If anything, I want to hear where I can improve. Establishing that line of communication with a mentor or someone who's more seasoned and experienced is so valuable. And just showing that you're open to constructive criticism and not having that ego barrier is so important. And I've done that every single co-op. So that is sort of a great way to establish that openness with your mentor.
Just to jump in that, actually, that's really good advice. Something that I didn't do in my first co-op, which was just establishing that constant feedback loop or feedback mechanism. So for example, what I've done ever since then is just like every week we meet and we go through just a list of things that went well, which didn't go well, and which things which could improve on. Something that I've been doing right now is every week my mentor gives me a score out of 10 of how that previous week went, just so that we can like objectively keep track of how things are going. In terms of being open and transparent, I'd suggest something that I did wrong was I hold myself as this technical person who's just good at building machine learning models and data engineering pipelines and all of that stuff, and just thought, oh, I don't want to interact with salespeople or product people because like that shit is useless. Like that's what I used to think at one point in my life. And I realized very soon after that that's not something that you should be doing. So be open to different areas so that you can get a holistic view of what's happening.
Right. Perfect. Thank you guys. Just to be respectful of everyone's time, we want to wrap up here. So thank you, our speakers, for sharing. It was super insightful, and I'm sure that our attendees definitely learned a lot from this panel. And just some shameless promo, be sure to follow us on our socials. We're on Facebook, Instagram, LinkedIn, and also Jay has an amazing podcast. So stay tuned for that and keep an eye out for our next event. So I guess I'll let everyone go now. Thank you guys so much for our speakers for speaking and everyone for coming.
I'm expecting an invite to this podcast. I haven't even heard of this podcast before.
Yeah.
Unlabeled Unstructured, man. The first episode drops next weekend.
Okay, you send me the link, man.
And I'll send you the link, yeah, for sure. All right.
All right.
Thank you,
Thank you,
Cindy.
everyone.
Thank you
Thank
guys.
you guys. Bye-bye.
Bye, everyone.